In this video, we will look at comparing linear functions. The first example is an equation and a table. And our question is, which function increases faster? So with linear equations, we're going to look at the slope because that is what tells us the rate of change. So in our first function, we have 2/3 as our rate of change, and then in our second function, we know that rate of change is really just the slope. So let's go ahead and find the slope. So rise, which is 10.2 minus 9.6 over run. So we have 1 minus 0. 10.2 minus 0.6 is 0.6 over 1 minus 0 is 1. So our rate of change for our table is 0.6, and our rate of change for our equation is 2/3, which 2/3 is really 0.66666, and I'm just going to say 0.67. I'm going to round it. So which one increases faster? Well, let's see, which one is bigger? 0.67. So g of t increases faster. The second question, which equation has a smaller starting value? Well, we know y equals mx plus b. The starting value is the y-intercept. So in our first function, we have 6 as our initial value. And we also know that if we have the y-intercept, which means x is 0, or in this case t, our independent variable, our initial value is 9.6. So which equation has a smaller starting value? Well, again, that's g of t. In this example, we are comparing an equation and a graph. Our first question asks, which function increases faster? So if we look at increases faster, that is our rate. In linear equations, we're going to look at the slope. In f of x, our slope is 1/4. If we look at q of x on our graph, we're going to start here at 0, and we're going to go up 1 and over 4. So our rise is 1 and our run is 4. So actually, they are the same rate of change. So I'm going to say that both increase at the same rate. In question number 2, which function has a higher starting value? So we know that starting values are our y-intercept, that initial value. In f of x, 1/3 is our starting value, and our y-intercept for q of x is right here at the origin, so our y-intercept is 0. So this is our y-intercept, and this is our y-intercept. Set 0. So if we compare those, 1/3 is larger, so our higher starting value is in the function f of x. In this example, we are looking at a table and a graph, and it asks us which is the smaller y-intercept. Well, generally, x equals 0 when we have a y-intercept. In this case, we have t and y. So our independent variable is x. And in this example, we have an independent variable of t. So we want to find out when t is equal to 0. Right here at negative 1.8. And then on our graph, we have a -2 as our y-intercept. They're asking us which one is smaller. If I look at a number line, -2 is here, -1.8 is here. So -2 is further left on the number line, so -2 is smaller. So that would be p of t, because we have our function in terms of t, has the smaller y-intercept. Our second question asks which function decreases. Well, decreases means going down from left to right, and in this case, our graph actually goes up. So that increases. So let's see if f of t decreases. So as our values increase by 1 on this side, on the f of t side, our values actually decrease. We're going down by 0.9 each time. So that would mean on our graph, we have -1, -0.9, 0, -1.8, we have 1, -2.7, and 2, -3.6. So if we were to graph, our line would go down, which means decrease. So in this case, f of t decreases.